some theorems from tangents and intersecting chords. So these are tangent properties of a circle. Okay, now if I look at a line which passes through a circle and it intersects the circle at 2 points, that is known as a secant. And if there is a line which is just touching the circle at 1 point, that is known as a tangent. So the tangent is any line which touches the circle at exactly 1 point. So there are some theorems based on tangents. The first theorem is about if I have a tangent to a circle, let's say in this figure PQ is a tangent and the tangent is touching the circle at point P. And if I draw the radius at point P, so let's say OP is the radius, then the radius and tangent will be perpendicular. So I can say that angle OPQ will be equal to 90 degree, or I can say OP is perpendicular to PQ. So this result is always true. This statement is always true. Moving ahead, if I have two circles touching each other, whether internally or externally, then if I look at the center of the two circles, for example, there are these two circles in the first situation touching each other externally, and the point of contact of the circle is point P. Then the 3 points A, P and B will be in the same straight line, or I can say that the point of contact P will be on the line which is joining the center of the two circles. The same thing happens when the two circles touch each other internally. Then also, let's say A and B were the centers of the two circles, and the point of contact P is on the line which is joining the center of the two circles. And let's say that if I wanted to find out the distance between the centers of the two circles, then let's look at the first situation where the circles are touching externally. Let's say that R1 was the radius of the first circle and R2 is the radius of the second circle. Then the distance between the centers, the length AB, will be the sum of the radius of the two circles. AP plus PP will be the sum of the radius of the two circles. That's the distance between the two centers. If I look at the circles touching internally, then if I want to find out the distance between the centers, which is again AB, in this situation, AB is same as AP minus BP. So which is basically radius of the first circle minus the radius of the second circle. So the theorem states that if two circles touch, the point of contact lies on the straight line joining their centers. Okay. Then another theorem which is very commonly applied is the theorem about tangents drawn from an external point. So let's say that P is a point outside the circle and I will be always able to draw two tangents to the circle. So here PA and PB, these are the two tangents that I can draw from the external point P. Then if I look at the length of the two tangents, I will find that the length PA will always be equal to length PB. So I can say that from any point outside a circle, two tangents can be drawn and they are equal in length. Now, there are a couple of other things which are also true. If I look at the center of the circle as O, and if I join OA and OB, then according to the first theorem that we saw, OB is perpendicular to PB, OA is perpendicular to PA. And if I join OP, then I will be able to prove that the triangle PAO and triangle PBO are congruent. And that's the reason why I can say that the length PA will be equal to PB. And also, some of the angles are equal. For example, angle POA. This angle POA will be equal to angle POB. Even I can say that angle APO will be equal to angle BPO. So these results come after I prove that triangle PAO and PBO are congruent. Okay. Moving ahead, there are some more theorems based on chords. So for example, in this theorem, we are looking at intersecting chords. The first figure shows two chords A, B and C, D intersecting internally at point P, and then the second figure shows two chords intersecting each other externally. So the point of intersection is outside the circle. So in both the situations, whether the chords are intersecting internally or externally, the same result is true, that the product of the lengths of the segments are equal. So in the first situation, when the chords are intersecting internally, my chords are AB and CD. But suppose for chord AB, the segments of the chord will be AP and BP. So the product AP into BP will be equal to the product of segments of the other chord. So the other chord has segments CP and DP. So this is true when the chords are intersecting internally. But if I look at the chords intersecting externally, it's still the same result. So for example, in the second figure, chords are intersecting externally. Again, I have two chords AB and CD. So if I look at the first chord AB, the segments will be the length AP and the length BP. So again, the product AP into BP, thus this product will be equal to the product of the segments of the other chord. So the other chord CD has segment CP and DP. So product CP into DP. So it's the same result in both the situations. Then if suppose I had a chord and a tangent intersecting externally. So here I have chord AB and tangent PT. So if I extend AB outside the circle, it will meet the tangent at point P. Then according to this result, the product of lengths of the segment of chord AB will be equal to the square of the length of the tangent. So again, the segments of chord AB will be AP and BP. So the product AP into BP will be equal to the square of the length of the tangent. The tangent is PT, so the product AP into BP will be equal to PT square. So this is the theorem, that if a tangent and chord intersect externally, then the product of lengths of the segments of the chord is equal to the square of the length of the tangent from the point of contact to the point of intersection. Then the last theorem is about the angle between a tangent and a chord. So for example, PA is a tangent and BA is a chord. So the angle between them is angle PAB. Now, if I look at angle PAB, this angle is being formed on the minor segment of AB, the minor segment of AB. Then if I look at the other segment, which is the major segment AB, there is an angle ACB which the segment is making, the segment AB, the chord AB. So then I will say that the angle PAB is equal to angle ACB. The same way, if I look at the tangent QA and the chord CA, they are making angle CAQ in between them. So angle CAQ will be equal to the angle made by the chord AC on the other side of the segment, which is angle ABC. So I can say that angle between a tangent and a chord is equal to the angle in the corresponding alternate segment. So these are the all the theorems that you need to know for tangents and intersecting chords.